The thing that the textbook doesn't tell you that kind of gets on my nerves is you are never going to compute a z or look it up in your whole life. And having these problems where you have to calculate the z statistic or the relative risk or the odds ratio. And I probably mentioned before, I have had many debates with other statisticians about this, and I would say maybe people fall 50-50. I am on the side of, so some people think that it's really important that you do the calculations, that you understand it. I don't personally feel that way, but the fact is, however you feel about it, once you get out of school, you are never going to compute a z statistic, and you are never going to look up degrees of freedom. You're going to use a computer, and you're going to look there, and it's going to say, hopefully, you will know this part. No one's going to run over and tell you this. It's going to tell you this is your null hypothesis. Often won't even tell you null hypothesis, but SAS very conveniently prints it on the printout in lots of places. So I did not compute this z with a pencil and a piece of paper. I hope you don't think less of me because of that. I actually used a computer, right there. And I found this was the frequency distribution. So I said, let's say somebody who's annoying me, which is most people, said, this whole COVID thing is because we're all fat and out of shape. More than, half the people in the country have some kind of pre-existing condition. We're all fat and out of shape and have diabetes and congestive heart failure and all these things. And so that's why we're all dying of COVID. And I would say, well, I don't think half the people in the country have a pre-existing condition. So I would, here is my test of my null hypothesis, proportion equals 0.5. I know this because it printed it right there. It's testing, in this case, it doesn't matter because it'd be 50-50, but it's testing that the first category here of these binomial probabilities of these two categories is 0.5. So there's my null hypothesis that the proportion equals 0.5, or the null would be there's no difference in the population from 0.5, which is what I hypothesized. And this tells me the z value, which I did not calculate with using the equations of the book, I used a computer, is 303.188. Now, y'all are used to thinking that if you have 30 or more people, that the z value is probably, if you have a large number of people, the z value is 1.96. And you don't even need to look it up to say 303 is a lot more than 1.96. And I have sat in meetings with people. I do a lot of consulting work and contract work for federal and state agencies. And I have sat there and looked at something, looked at a square table or looked at a binomial table like this and said it's statistically significant. And people are like, oh, Dr. Marsh, she's so brilliant. She's so amazing. You know what went through my mind? 303 is a big number. That was my brilliant, amazing thought. And since 303 is a big number, and it's a whole lot larger than 1.96, I'm sure it's statistically significant. And down here, it's telling me that for a two-sided probability, a two-sided test, the probability is less than 0.0001 or 1 in 10,000. Also for a one-sided test, just because it's way less than 10,000, right? If it was closer, these would be different. So that's what you're going to do for pretty much your whole life. You are not going to do any of these equations by hand. And that's why I started out saying, I'm all for ChatGPT, because I felt like for years we're having people do this stuff and compute the sums and squares and compute the odds ratio, confidence limits, and nobody really does that. Here's my binomial proportion confidence limit. It was also printed on the same printout. If you get these results, here's what you are going to need to do, and nobody's going to do for you. You're going to have to look at this and say, is the null hypothesis projected? Is it plausible that 50% of the people in the population have a pre-existing condition? And the answer to that is no. And so then the person who wants to argue with me is going to say, well, Dr. Mars, how do you know that? Well, because the probability of getting a z value this large by chance is less than 1 in 10,000. And also, it's not even close to 50%. because when I look at our 95% confidence limits here that we got from a population of almost 1 million people, because there's my cumulative frequency, 990,000. When I look at our 95% confidence limits, they're from 65.1% to 65.3%. So that's telling me that with a fairly large degree of certainty, 65% of the population of this country does not have a pre-existing condition. So that is what you are going to need to be able to do. You are going to need to be able to take these data, these results that you get, and interpret them. And I will tell you two things. Now, the end of this story is that she did pass her exams in the end, and she got tenure and has since retired as a full professor. But when I was getting my doctorate, there were a few of us, and we all studied together. We were like you guys in the same cohort. We would get together and study for our exams. And she says, Anne Marie, I failed my written. And I said, oh, Gabby, come on, I'm sure it wasn't that bad, you know. She says, yeah, I failed the statistics part. And I said, oh, I'm sure you didn't. I'm sure it was that bad. She goes, oh, it was that bad. I did not even have the nerve to leave it blank. She said the question was, what is the pseudo R squared and how you get it? And I said the pseudo R squared is the square of the pseudo R, and how you get it is the computer gives it to you. And I said, okay, I don't think that was the answer we were looking for. And she said, no, I don't think so either. But anyway, she retook it. She got it right. Yeah. So the answer wouldn't be necessarily because the computer says so, but because the probability of getting a z-value this large by chance is less than 1 in 10,000, which is a heck of a lot less than 0.05, which means the probability of this just being random, biased in sampling is very, very small. We have a very small confidence interval because we have a very large sample. So I'm fairly confident in saying that no, you are wrong. And oh, here's my null hypothesis that the proportion is 0.5. So that's what you're going to do for most of your life. Do not, because it will not help you in this class. It won't help you in the next class. It will not help you in your career. Try and weasel around things. Don't tell me, and I've done this too, so I'm not going to judge you. Don't try and tell me everything but the answer. If I say, do you reject the null hypothesis or not? That's not an essay question. That's a yes or no question. And so either yes, you reject the null hypothesis, or no, you don't. So yeah, that's what you're going to be doing in your career, and then justify that. So with the other thing to know, is with a large enough sample, almost everything is going to be significant. Because, and going back to my same friend, Gabby, who really is very smart, but statistics was not her strong point. The person who was the chair of the statistics section where we got our PhD, he was being kind of mocked by some of the other professors about the students didn't learn statistics that well. And so he called in one of the students, and one of the other professors says to her, what does it mean if you reject the null hypothesis? And she said, I think that means it's very, very important. And then he was mortified, and he called in another student, and he said, yeah, Dr. McMillan asked her, what does it mean if you reject the null hypothesis? And she said, it means it's very, very important. What do you think of that answer? And she said, well, that sounds like a good answer. That is not a good answer, okay? What it means if you reject the null hypothesis is it's very unlikely that the difference is zero, that the difference between the means is zero, that the difference from your hypothesized proportion is zero. It's very unlikely that it's zero. It's very unlikely that the difference between the odds is zero, or the difference between the relative risk is zero. That's what it means, that there's not a zero relationship. Well, guess what? If you have a large enough sample, almost anything is going to turn out to be statistically significant. Because what we're saying is, what's the odds you would get a difference that large by chance? So let's say there's a difference in proportions of 0.03 or 0.01. If you have 100 million people, that is statistically significant. It's not zero. Is it important? Well, maybe if it's, 47% of the people died that were male and 50% that were female, then you might think that 0.03 is important. If it's 87% had complications if they were male and 84% if they were female, maybe not. But tiny, tiny differences are also not zero. And if you're a clinician, if you work in the hospital, if you work with patients, you're probably very familiar with the idea of clinical significance versus statistical significance. So somebody might have a temperature of 98.7 instead of 98.6. And if you have a large enough group of people, that difference might be statistically significant. Is it important? No. So keep that in mind. And I think this is a really important point because a lot of people who only learn enough statistics to be dangerous, as a friend of mine said, they'll say, well, it's statistically significant. Yeah, it's not zero, but it's tiny. So you need to look at the size of the difference as well as statistical significance. The flip side of that is that if you have a small sample size, almost nothing's going to be statistically significant. Remember, you're dividing out standard error by the square root of n. So again, if you're have a small sample and you see major differences, then maybe what you need to do is repeat that study with a larger sample and see if in that case you do repeat the large difference and if it really is something that's statistically significant. But yeah, if it's a large sample, almost like I said, I used to work with databases that would be like every child in the state of California that was diagnosed with a disability. Everything we did was going to be significant. Same thing if we're looking at Medicare claims data, everything's going to be significant. So we're looking at not just we do look at rejecting the null hypothesis, because if it's not significant, boy, it's a tiny difference. But we also look at the size of the odds ratio, the size of the relative risk. So that the secret of what you're going to be doing with hypothesis testing. And so now you are going to do your own. And this will be the part of the class that you remember 6 months from now when you forgot all this other stuff, because it's going to be the thing that you're going to do.